Hello, good morning, dear students. Today we'll start our next chapter, that is chemical kinetics. Okay, so stay at home, enjoy the session. Chemical kinetics. Okay, so chemical is nothing but your chemistry or chemical compositions, or what is about kinetics. The word kinetics came from a Greek word, that is kinesis, and kinesis means movement. Okay, so till today we read about the reaction feasibility, how a reaction is feasible from the thermodynamic, whether del G greater than 0, less than 0, spontaneity. And again we read about the time taken or the equilibrium, when a reaction is achieving equilibrium, where the reaction, forward reaction or backward reaction, okay, when it will reaches the equilibrium, about the concentration. So here we will read the rate, particularly the rate of a reaction. How much, what is the rate behind? Rate is the, what is rate? Rate is nothing but the speed, time. Okay. So apart from that, kinetics is the step by step. That means up to half of the reaction, how much time it takes. Up to complete the reaction, how much time it takes. So these are the factors, depends upon the, what are the factors depend upon the chemical kinetics or chemical reaction. And again we will read how much, what is the influence of these, or what are the mechanism of these reactions. Okay, so here basically we will read about the movement or rate of a reactions. Okay, both the side, product side as well as reactant sides. Okay, and as we know that every reaction has three categories: low, fast, moderate reactions. How it affects these reactions, what are the composition, and what is the mechanism behind, what are the significance as well. So these sort of things we will read in this chemical kinetics chapter. Okay, so let's start. So chemical kinetics, very important chapter. So as I told, kinetic means, or it comes from a word kinesis, means movement. Take out a copy, write little things. So is chemical kinetics, it is the branch of science which deals with the study of, what? As I said, it deals with the study of rate. Okay, study of rate and the mechanism behind the chemical reaction. Okay, branch of science which deals with the study of rate of a reaction and the mechanism behind how the reaction proceeds, what are the mechanism, what are the steps. Okay, how will you determine the rate? So all sort of things we're going to read in this chapter. Okay, suppose you have the conversion of milk into curd, the food spoils, right? If you will keep a food at a room temperature at your home place, you get to know that after 1 day or 2 days that food, the foul smell comes from that food, right? So how much time for rice it takes, different time for apple it takes different time. So these chemical reactions, how much time it takes, so all sort of chemical reactions, the rate and the mechanism, what are the reason. So we will read in this chapter. So as we know, rate depending upon the rate, the reactions depending on rate of reaction. Rate means the time taken. Depending on the time, how much time it takes, depending on that, it has been, the reactions has been classified into three categories. These are, first one is slow reaction, okay. Second one is what? Moderate reaction, or average reaction, you may say, or average reaction. And third one is that fast reaction, fast or instantaneous reaction. Okay, slow, moderate, and fast or instantaneous reaction. So slow reaction, rusting of iron. Very good example. From the childhood we know that the slow reactions, rusting of iron. Okay, if a reaction slows, means it will take year of times to complete the reaction. And moderate reaction or average reaction, in this reaction we can easily calculate the rate, how much time it takes, maybe 2 days, 3 days, or 1 day, or some few hours, where we will get to know the concentration of the reactant, concentration of the product, how much time will take. That these all sort of things is the average reaction. Fast reaction, this happens in a fraction of time. Okay, cracking of fire, once you lighting the fire, it will blast, bomb, right? So cracking fire is the instantaneous reaction. If you will talk about a chemical reaction, whenever you will add uh, HCl plus AgNO3, what you will get? Ultimately AgCl will form, and we know that AgCl is white precipitate. The precipitation of AgCl, silver chloride, is a instantaneous reaction. Once you tries to add, these both are colorless, once you add, ultimately the milky white color precipitation will come in your test tube. That is what the instantaneous reaction. Okay, so these are basically three type of reactions: slow, moderate, and fast. You can give the examples anyway. So rate, how will you calculate rate? Rate of any reaction. Rate, basically, how will you calculate? So that is what? Change in concentration. Change in concentration of what? That may be reactant or product. If you want to calculate the rate of a reactant, that may be that you have to consider the reactant part, or if you want to calculate the product concentration or product rate, then you need to consider the product. Change per unit time, yes, this is how we need to calculate the rate. Suppose we are writing kilometer per hour, the distance, traveling distance. So what is the rate of your speed? That is what? Kilometer per hour. This much kilometer you covered in an hour. So here also, in a second how much reaction proceeds. How will you know? By calculating the change of concentration of reactants or the product side. Okay, so here two things are happening. Suppose if you will consider R is a reactant and it gives product P. Okay, R is reactant and P is the product. For this, what will be the rate? Rate will be rate of disappearance. So what is disappearance? New term came, disappearance. See what happens. Once the reaction R converts to the product P, what happens to the R? R got disappeared, or R changes to P, R got reduced. Suppose the 100% concentration of R is there, and when it will form the product, the concentration of R will be 0 or less than the 100%, obviously, because the R utilizes itself to give the product. So this R, what happens to the R? R got disappeared. So the rate of disappearance, here I am writing here, rate of disappearance, rate of disappearance equals to, what will be the concentration over here? So decrease in concentration of what? Reactant. Why decrease? Because it disappears. So decrease in concentration of what? Reactant divided by change in time. How much time is taken? Okay, so let me clean, I'll make you understand again. So what is rate? Rate equals to change in concentration of reactant or product per unit time. Okay, so change in concentration of reactant and product per unit time, that is what rate. Okay, suppose a reaction R gives rise product P, reactant R gives product P. So time 1, let's say T1 and T2, we will consider 2 time over here. So at T1, suppose the concentration of R is R1 and product concentration is P1. Suppose at T2 R concentration is R2 and product concentration is P2. So see what happens, the reactant side R will disappear. So rate of disappearance ROD, that is what? Disappearance, ROD, rate of disappearance equals to, how will you calculate? Decrease in concentration of what? Reactant divided by, or change in time. So you can write these things minus del R concentration by del T. So where I got this del R? Del R is nothing but change in concentration of reactant, that is here I am writing del R, or del R equals to what? R2 concentration minus R1 concentration. Okay, so change in concentration is your del R, and del T is again same, del T is equals to change in time. So this is what? ROD. If I will ask what about the product, one more thing, this negative sign, why I am putting here negative sign? Because of decrease. Reactant, what happens? Decreases. Reactant decreases. Simultaneously in product side, if you calculate ROA, that is rate of appearance, ROA, that is appearance, rate of appearance, that is what? You need to put plus sign. So what will be the formula? Increase in concentration. What it said? Increase in concentration of what? concentration of product divided by change in time. Change in time. Okay, so what will be the mathematical expression? That is del P concentration, del into concentration of P divided by del T. Simple. If I will say calculate ROD and ROP of any reaction, you can calculate. Okay. So note it down everything. Okay. So what will be the unit of rate? Now we can know the unit of rate. See, change in concentration of reactant. So concentration, what is the unit of concentration? We know that mole per liter. That is what concentration unit, whole divided by unit of time. That is we need to take in second. Okay. So mole liter inverse second inverse is the unit of rate. Okay, let me clean. Now consider a reaction. Hg, mercury liquid plus Cl2 plus Cl2 gas gives rise to HgCl2. Okay, mercuric chloride. So write its ROD, that is rate of disappearance. So this will be nothing but negative R Hg concentration by del T, and again equals to negative del Cl2 concentration by del T. This is how you need to write ROD. You not need to write the product side. Okay, rate of disappearance means you have to write only the reactant part. Okay. If I'll ask what is ROA, that is rate of appearance, this will be become del of HgCl2, concentration of HgCl2 by change in time, positive. So what will be the ROR, rate of reaction? Remember, whenever the case is for 1 mole, always you need to calculate for 1 mole. That is what ROR, rate of a reaction. Likewise, when when we are calculating the speed, that is kilometer per hour. Okay, per hour, always we are calculating the speed or the distance covered per hour. That is what km per hour. So for ROR, you have to divide its stoichiometric coefficients. As I told, we need to calculate per hour. So 1 mole, we need to calculate per mole. Okay, 1 mole, what is the rate? The reaction for 1 mole of completion of reaction, what is the rate? So for that reason, we need to calculate, we need to divide the stoichiometric coefficients. So here, what will happen? The ROR will be, you need to write like this. Minus 1 by 1 del Hg concentration by del T. Again, this 1 by 1 because the stoichiometric coefficient is 1 here. This is again 1 here. So minus 1 by 1, because you no need to write here because of 1. Okay. If 2 is there, then 1 by 2. Okay, we'll go to next example. So del of Cl2 by del T, and again equals to 1 by 1 product, that is what, del HgCl2 by del T. So here you need to write reactant side as well as product side and by divide the stoichiometric coefficients. Okay, let us take another example, and that is suppose 2Hi gives rise H2 plus I2. So here what will be the rate of reaction? This is again gas, this is again gas. So ROR, so this is how you need to write, minus 1 by 2. See the stoichiometric coefficient is 2 here. So I have to calculate for 1 mole. So del Hi, the concentration of Hi divided by del T. The concentration must be given in your question, and is equals to, this negative sign is due to the reactant or disappearance. You have to write this product again for the ROR, that is what, this is coefficient is 1 here, so 1 by 1 del of H2 concentration by del T, and again equals to 1 by 1 del of I2 concentration by del T. I hope you have cleared this one. Doubt clear? Okay, so I'm giving one more. You need to do it at your home and do it in comment section also. Okay, shall I clean it? Yes, pause it and write the question. Which one? Okay, this one we can do it. N2O5 gives rise to 2 N2O5 gives rise to 4NO2 plus O2. This one. Yes. So write its ROD, find its ROD, again ROA, again ROR. So in case of ROD and ROA, you no need to divide that stoichiometric coefficient. For particularly ROR, rate of reaction we need to calculate for 1 mole. Okay, so for that reason you need to divide the stoichiometric coefficient. Again I am repeating, for ROR only you have to divide the stoichiometric coefficient, not for the ROD and ROA. Okay, thank you, see you in next video.